All right, hi everybody. Today we're going to be talking about the midpoint and distance formulas, medians of triangles, and ways that we can use those formulas. This is, again, something that you've seen before. It's not going to be anything new to you. We're just maybe using these formulas in a little bit of a different way than we did in the first trimester of this class when we talked about basically the same things. So we've got some vocab. The first two are just formulas. We know these formulas already. So for both the midpoint and the distance formula, you're given 2 points to start out with. We're finding the midpoint between 2 points, or we're finding the distance between 2 points. So we've got the point x1, y1, and we've got the point x2, y2. So both the midpoint and the distance formula are based off those 2 points. For the midpoint formula, as you might remember, we're going to make a new coordinate point. And in the new coordinate point, the x-coordinate is going to be the average of the two x-coordinates. So we're going to say x1 plus x2 divided by 2. And the y-coordinate is going to be the average of the two y-coordinates. So we'll say y1 plus y2 divided by 2. So those are the midpoint formulas that you're going to need. For the distance formula, it's going to use these same 2 points, x1, y1, and x2, y2. And to find the distance between those 2 points, we're going to use the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, you've seen that formula before. We also learned last time we saw the formula that it's basically the Pythagorean theorem all put together in one step. So the same way that the quadratic formula is completing the square all put together in one step, the distance formula is that same compilation of all of the steps of a formula to give you one streamlined formula. And then to find the median, not actually to find the median, but the definition of a median, you've also seen this before, you might remember it. A median is a line from the vertex of a triangle to the midpoint of the opposite side. So a line from the vertex of a triangle to the midpoint of the opposite side. And we saw medians last try, although they were something that you generally maybe struggled with more than any of the other things we saw. So it's a good thing that we're going to come back to them and be able to talk about them again. So first of all, general, finding the midpoint of and the distance between these 2 points. So we've got negative 10, 27, that's going to be our x1, y1, and negative 3, 3 is going to be our x2, y2. So to find the midpoint, first of all, we'll put MP for midpoint. It's going to be a new coordinate point where the x-coordinate is the average of the x's. So negative 10 plus negative 3 divided by 2. And the y-coordinate is the average of the y's. So 27 plus 3 divided by 2. So then we can just figure that out. Negative 10 plus negative 3 is negative 13. Negative 13 over 2 is negative 6.5, although if you wanted to write negative 13 halves, that could be the same thing. 27 plus 3 is 30. 30 over 2 is 15. So your midpoint is negative 6.5 and 15. The distance then is going to be using the distance formula. So we'll put in the square root of x2 minus x1. So negative 3 minus negative 10, make sure you do that, squared, plus y2 minus y1. So 3 minus 27 squared. And then we just reduce here. So we take that, the square root. Negative 3 minus negative 10 is 7, so that's 7 squared. Plus 3 minus 27 is negative 24, so that's negative 24. I'm going to put that in parentheses there, squared. And we just complete this. So 7 squared is 49. 24 or negative 24 squared is 576. So if we put those together, we've got the square root of 49 plus 576 is 625. And if you put that in your calculator, or if you know this, the square root of 625 is 25. So the distance between those 2 points is 25 of whatever unit we're measuring in, 25 graph blocks, I guess. Next one down here, the length of the median. This says find the length of median AC, but it should say a different median here. And I did change that in your completed notes also. It should say median BD. Sorry about that. So find the length of median BD in the triangle at right. And you notice that this triangle is triangle ABC, and there's no point D at all. So that's going to indicate to us where this median is going to be, because there are 3 possible medians of the triangle. But if it says median BD, we know that point B is part of the line of the median, or an endpoint of the median, which means the other endpoint must be the midpoint of the opposite side to point B. So the midpoint of AC is going to be helpful to us in finding the length of this median. So first of all, we're just going to put down the coordinates of each of these points so they can help us out. So B is at 3, 4, C is at 9, 4, and A is at 3, 8. So first of all, we've got to find the midpoint of AC because that's where point D is going to be. So we can go over here, we can use the midpoint formula with A and C, so average these. So we've got 3 plus 9, x1 plus x2 over 2, and then 8 plus 4 over 2 for our y coordinate. And then we say, well, 3 plus 9 is 12, 12 over 2 is 6, and 8 plus 4 is 12, 12 over 2 is 6. So the coordinates of the midpoint of that line are 6, 6. So we can go over here, over 6, up 6. There is point D. That's the midpoint, and that's going to be at 6, 6. All right, after that, we want to find the length of the median. Length and distance are the same idea when you're looking at a coordinate plane. So to find the distance between B and D, we're going to use the distance formula. So B is 3, 4, and D is 6, 6. We can go ahead and plug those in. x2 minus x1 will be 6 minus 3 squared plus y2 minus y1, which is 6 minus 4 squared. And then we can go in here, 6 minus 3 is 3 squared plus 6 minus 4 is 2 squared. 3 squared is, I'm going to put an arrow here, 3 squared is 9 plus 2 squared is 4. And we end up with the square root of 13, which of course doesn't simplify in any way. So we can call the square root of 13 the answer. That's the exact answer of our distance between those 2 points, which means it's the exact answer for the length of median BD. We can draw that in if we want. The next one is something that I don't believe we ever did last try, but it's the same, basically the same ideas that we've been using, nothing crazy here. So it says, what is the center of a circle with diameter endpoints 7, negative 15, and negative 3, 6? And what is the area of the circle? So to find the center of the circle, we know we have the endpoints of the diameter of that circle. So here's our circle. We know that the diameter is going to go straight across, and here are our endpoints, which means that the midpoint of that diameter is going to be the center of the circle. So we just have to find the midpoint of these 2 points. Easy enough, x1 plus x2, 7 plus negative 3 over 2, y1 plus y2, negative 15 plus 6 over 2. So then that gives us 7 plus negative 3, that's 4 over 2, which is 2. And negative 15 plus 6 is negative 9. Negative 9 over 2 is negative 4.5. You could leave it in fraction form, but we're going to need to use this. So I'm going to put it in decimal form just so it might be easier to do calculations with it. So we found the midpoint, or the center of this triangle. And wow, it's a circle, not a triangle. And so then we need to find the area of the circle. We're going to use the center point and one of the other 2 points. Because if we find the distance between the center and one of these 2 points, we'll find the radius of that circle, which is what we need to find the area. So let's see, we'll use just this first point here. So we'll use 2 points. We'll use the center, 2 and negative 4.5. And we'll use this endpoint here, 7 and negative 15. You can use the other one too, that's totally fine. And we're going to find the radius here by finding the distance between these 2 points. So we'll go ahead and set up our distance formula, x2 minus x1, 7 minus 2 squared plus negative 15 minus negative 4.5 squared. And we get that together, that gives us 5 squared plus negative 15 plus 4.5 gives us negative 10.5 squared. So this then is 25 plus negative 10.5 squared happens to be 110.25. And if we add those together, we get the square root of 135.25. And since we have a decimal underneath the radical, we want to just keep going until we get a decimal approximation for our answer. So we'll just keep going here and we'll say, well, the square root here, if we put it into a calculator to find that decimal, is approximately 11.63. And that's also the radius of the circle. So this distance from the center to the endpoint is going to be the radius. We know the area formula for a circle. That area formula is pi r squared. So we'll just plug that in. So the area is going to be pi times 11.63 squared, which then, if we figure that out, we can leave it in terms of pi. It's going to be 135.25 pi. That shouldn't be a surprise to you because over here we had to take the square root of the number to get the radius. And if we have to square it again to find the area, that number comes back to us. So the area of this circle is 135.25 pi. All right, let's go ahead and flip this over and get to the rest of the notes. Just a couple here. We want to prove that something is an equilateral triangle, or in this case, actually prove whether something is an equilateral triangle. And we know equilateral triangles have three sides that are all the same length. Luckily, we have the 3 points that are the coordinate points of the vertices of our triangle. And so what we need to do, or what we would need to do to prove that this triangle is equilateral, is we would need to show that each of the side lengths, maybe we'll call these points A, B, and C, we need to show that each of the side lengths between those points are congruent to each other, the distances of those side lengths. So one of the sides is going to be the side between A and B. So I'll say AB with a line over it, that's line segment AB. That needs to be congruent to the other side. Another side is BC, they're right next to each other. And the third side of this triangle loops back around, so C to A. So it's congruent to AC or CA. And if this is true, we'll say show that this is true. And if all of our sides are congruent to each other, then our triangle is equilateral. So we'll find the distance between A and B. So the length of side length AB. I'm going to go ahead and draw that. So we're using just point A and just point B here. So we're going to say x2 minus x1. So 3 minus negative 3 squared plus y2 minus y1, 3 minus 3. 3 minus 3 squared, and we'll figure out the distance here. So that's going to be the square root of 6 squared plus 3 minus 3 is 0, so that's 0. 6 squared is 36. The square root of 36 is equal to 6. So side AB is 6 units long. So then we've got to see that side BC and side AC are also 6 units long. So we'll go with side BC next, and we will go ahead and find this distance. So we're going to say, all right, BC, x2 minus x1 will be 0 minus 3 squared plus y2 minus y1, negative 3 minus 3 squared. And we'll solve this out. So 0 minus 3, that's going to be negative 3 squared plus negative 3 minus 3 is negative 6 squared, which gives us 9 plus 36 gives us the square root of 45. The square root of 45 reduces to 3 root 5 if we want to put it in simplest terms. But 3 root 5 and 6 over here, they're not the same. So these two side lengths aren't the same length. We don't even need to test the third side length because we were trying to find if it was equilateral. And we know for sure now that this is not equilateral because at least 2 of the sides don't match up. So that's all we need to do. We showed that we could not prove that these 3 side lengths were the same. All right, and then finally this last one, finding endpoints when we're given a midpoint. So we've been given the midpoint. If A is 5.2 and then 9, negative 7 is the midpoint of segment AB, we want to find the coordinates of point B. This is one of those problems where we're going to use the formula to help us out. We know that here is one endpoint, so maybe we'll call this x1, y1, because that's one of the endpoints. And we also know that the midpoint formula is going to help us here. So the midpoint formula would be the x1 plus x2 over 2, comma y1 plus y2 over 2, that coordinate point. So if the x coordinate of the midpoint is 9, then we know this expression, x1 plus x2 over 2, is equal to 9. So we can say x1 plus x2 over 2 equals 9. That's the x coordinate. And we know x1. We just labeled it up here. That's 5. So 5 plus x2 over 2 equals 9. Then we just solve this equation to solve for x2. So we've got to multiply both sides by 2 first. And we get 5 plus x2 equals 18. Subtract 5. We get x2 equals 13. Notice, and be making sure you're careful, this isn't x squared, it's just x2. So we're not taking a square root or anything, because this is just the already answer, x2 equals 13. Do the same thing with y. We know that y1 plus y2 over 2 is equal to the y coordinate of the midpoint, which is -7. So we're going to go ahead and take that. And then just solve this equation, multiply both sides by 2. And we've got y1, I'm going to replace that y1 with the y1 coordinate, so 2 plus y2 over 2, whatever, I'll just start this over. 2 plus y2 over 2 equals -7. And then, like we said, we're going to multiply both sides by 2. So 2 plus y2 equals -14. And then we will subtract 2 from each side. And we get y2 equals -16. So the y coordinate of our second point is -16. We can put those together. It says, what are the coordinates of point B up there? So we can say, well, that's going to be 13, -16. So we found the coordinates just by using the first point and the midpoint. And that is all for section 2. So go ahead and do the worksheet that goes along with section 2. Hopefully you got everything that you need out of this video. And always contact me with any questions you have. All right, thank you. Have a great day.